Hello everyone. This video is about the basic terms and definitions you need to know and some key concepts you need to understand for your O-level chemistry exams. I hope this video becomes helpful to you all, as some of the definitions are not directly given in books, and in your O-levels you will get one or two definitions to write. Here are the contents that I'll be covering in this video. Atom. An atom is the smallest electrically neutral, indivisible particle of an element that take part in a chemical change. This definition is quite of a mouthful, but we can simplify it into an atom is the smallest particle of an element. Now, this definition is applicable only for O-levels, because if you search in the internet, you can see that neutrons and protons can further be broken down into substances called quarks. O-level candidates, no need to mention about quarks. Now, what are neutrons and protons? Atom contains three things: electron, neutron, and proton. The differences are: electrons are negatively charged, neutrons have zero charge, protons are positively charged. Electrons have zero mass, neutrons have mass, so as the protons. Now, electrons are located outside the nucleus. Neutrons and protons stay at the nucleus. Now, the center of every atom is called the nucleus. In the nucleus, neutrons and protons reside. The circles that you see are called electronic shells. The shells are the pathways where the electrons move around the nucleus. This whole thing makes one atom, and thousands and millions of atoms make an element of substance. Some terms and definitions. Atomic mass number. Number of protons and neutrons present in an atom. Atomic number. Number of protons in an atom. Proton number always equal to electron number in an atom. Relative atomic mass. The mass of an atom compared with the 12th part of carbon-12 isotopes. Relative molecular mass. The mass of a molecule compared with the 1/12th part of carbon-12 isotopes. Now, relative atomic mass and relative molecular mass, these two terms are quite important because you have to mention the carbon-12 isotopes. Atoms of different elements have different number of protons, neutrons, and electrons, thus they also have different number of shells. Now, all the elements that exist on our planet are given a specific symbol. This element shown here is actually helium gas. Now, in your textbook, if you turn the pages, you will see a big chart in the very end of the book. This chart shows some specific symbols. These symbols represent specific elements. You will also observe that there are two numbers. These numbers on the symbols actually represent the atomic number and the atomic mass. Now, depending on the book, the number may be in different position. Always remember that the atomic mass number is greater than the atomic number. Ions. Any charged particles. Atoms can also become ions. By losing electrons, an atom becomes cations, or positively charged ions. By gaining electrons, an atom becomes anion, a negatively charged ion. Now, electronic configuration. You have to really focus on what this term means. It tells us how many electrons are around a nucleus and in what order. The first shell can only fill maximum of 2 electrons. The second shell, 8 electrons. The third shell can fill 8 electrons or more. Now, how to know how many electrons are at which number of shell? The formula is 2n square, and n is the number of shell. So, the first shell always contains 2 electrons. The second shell will contain 8 electrons. The third can actually contain 18 electrons, and the fourth 32 electrons. I have included a special note here. From the third shell onwards, 8 electrons enter first, then 2 electrons go to the next higher shell, and if any electrons are left, they fill the third shell. For example, iron contains 26 electrons. So arrangement is 2, 8, then 8 plus 6 and 2. This is not required for O level, but if you're wondering why transition elements have weird configuration, this is the reason. Octet rule of valency. Every atom has a tendency to attain 8 electrons at their outermost shell. Every atom has a tendency to attain the electronic configuration of its nearest inert gas. To attain the electronic configuration, atoms lose or gain electrons by forming ions. This is the modified octet rule of valency. Now, octet rule of valency is very important, and you should really remember this. If the outermost shells are completely filled with electron or contain 8 electrons, the atoms become very stable. The reason why the noble gases are stable and don't react is because their outermost shells are completely filled. Terms and definitions again. Valenced electron. The electrons present in the outermost shell of an atom. Valency. Number of electrons atom lose or gain in the outermost shell to attain octet rule is called valency. Now these two terms are very important. You really should know the difference. The difference is, as you can see, there are 3 elements here: sodium, chlorine and argon. Now what will be their valenced electrons? For sodium, the outermost shell contains only 1 electron. For chlorine, the outermost shell contains 7 electrons. For argon, the outermost shell contains 8 electrons. The valency is the number of electrons that they can lose or gain. For example, sodium loses 1 electron and becomes positive. Chlorine can actually gain 1 electron and become negative. Argon needs no loss or gain of electrons. And this is very important to know. Radicals. Group of atoms sometimes work together as a single atom and take part in chemical reactions without breaking down. For example, sulfate. Molecules. Smallest part of an element or compound that shows its properties. A molecule can be made up of same atoms or of different atoms of different elements. A molecule can be made up of 1 or more atoms. Example, ozone. 3 oxygen atoms make 1 ozone molecule. Now the differences between atoms and molecules. Atom is the smallest singular entity of an entity. Molecule is made of 2 or more atoms. Atom consists of subatomic particles known as the protons, electrons and neutrons. Molecules consist of more than 2 atoms, which can be either of the same element or of different element. Atoms are not stable alone. Molecules are stable alone. Atoms cannot be separated into subatomic particles by chemical reactions. Molecules can be separated into atoms by chemical reactions. Better to know the difference or you will mess up calculations. Yes, chemistry does have some maths. Moles, not the animal mole. Mole is the molecular mass of any substance expressed in grams. So, for example, molecular mass of oxygen is 32. Now, why 32? 1 mole of oxygen is 32 grams of oxygen. Here you can see that 1 molecule of oxygen, there are 2 atoms. Now, 1 oxygen actually has an atomic mass number of 16. So, 16 plus 16 is equal to 32. Now, there are some elements that exist as divalent molecule, and oxygen is one of them. Another example is hydrogen. It exists as H2. Avogadro's number, the magic number, and you have to know this number all the time, and it will be included during your mathematical chemistry questions in your O levels. According to Avogadro, a scientist, 1 mole of any substance contains 6.023 into 10 to the power 23 number of particles or molecules. So 1 molecule of any gas at room temperature and pressure occupies a volume of 24 dm cube, or 1 mole of any gas at standard temperature and pressure occupies a volume of 24,000 cm cube or 22.4 dm cube. Now, when you are giving your O-level exam, if there comes a math where you have to do the Avogadro's number, be sure to check the question, what condition they are giving. Are they asking you to calculate the mole number, the particle number at room temperature and pressure, or at standard temperature and pressure? Now, equal volume of all gases at same temperature and pressure contain the same number of particles. So, the formula for mole is mass divided by RAM. Here RAM is relative atomic mass. So mass is moles into RAM. I know this is not that much of an important formula and it's obvious, but it helps to have it written. Compounds. A compound is a substance formed when 2 or more chemical elements are chemically bonded together. Example, water. Water contains 2 hydrogen atoms and 1 oxygen atom, and the formula is H2O. What is a chemical bond? It is the force of attraction between the atoms in a molecule. Bonds. Ionic bond, covalent bond, and metallic bond. These are the 3 types of bond you will be studying in your O-level chemistry, for your O-level chemistry, and I will be discussing about this 3 bond in my next video in details. Thank you for sticking till the end. I will upload more detailed notes in various chapters in the next videos. Feel free to subscribe so that you don't miss any upcoming notes, and if it really helps, feel free to ask questions about things you need more information about in the comment sections down below. Now, if you want to download the file, go to the link given in the description below, and it's totally free. Thank you again.